Hi guys. So today what I want to talk about is the concept of expanding binomials. So first I want to review something that you guys did last year, and it's expanding brackets. Okay. So do you remember how to multiply this? You have to first multiply the 2 to the first part, and then multiply the 2 to the second part. Okay. So I also want to show you what this means with algebra tiles, okay? Because I'm going to use algebra tiles quite a bit. So since it's multiplication, we're going to pretend like it's a problem of finding the area of a rectangle, right? So this 2 here, because length times width is going to give us the area, right? So that 2, I'm going to treat it as the width. So I'm going to put out 2 single tiles. And then 3 minus x, well, here's 3. And here is a negative x tile, right? And then do you remember our job with algebra tiles is to now try to fill in this area here with the right amount of tiles and with exactly that amount of tiles, okay? So what you should notice is that right here we've got 1, 2, 3 spaces, but we've got it twice. So that makes it necessary for us to have 6 tiles. So there's 1, 2, 3, 4, 5, 6, right? And then we also have 1 times an x tile. So I'm going to have an x tile there and another x tile. Okay? So that means that here I'm going to have x and x. And that actually gives me my answer, right? So I've got 6 and I've got negative 2x. Okay? So the red tiles we're always going to use as positive. So this is positive, 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 and positive, right? And all the other colors we're going to use as negative. Okay? So there's my answer. Now, I want to show you that we don't need algebra tiles, right? Because if we remember back to our problem like this, we could just see that our answer is 2 times 3, 2 times negative x. Okay, so both ways, same answer, but I do want to know how to use the algebra tiles because we're going to use them a little bit more when we get to our next term. Okay, so I also want to give you another analogy that I like. So say this guy comes to this party, all right? And so he walks up to the house, okay? There's no one there, but he walks up to the house, right? And in the house, there are 2 people, okay? So they're having a good time. They're dancing, busting a move. And so this guy here doesn't want to be rude. So realistically, he has to say hi to this guy, and he has to say hi to her, right? So you see how he actually gets distributed to both people. So he goes there and he goes there. Okay? So that's actually why this number repeats twice. Okay? Because this guy has to say hi to both people at the party. Alright? So that means here, this 2 has to distribute to the x and it has to distribute to the 3. Right? So the 2 goes and says hi to the x, and the 2 goes and says hi to the 3. Okay, so here we would have 2x plus 2 times 3. Okay, alright, so that's all a review of last year. So this year what's new is I've got a bracket and then another bracket. Okay, so first let's see what that looks like with algebra tiles. Okay, and then we're going to break it down using the math. So with algebra tiles, I've got an x plus 1, and the length, I've got x plus 2. Okay, so now our question becomes, well, right here, what tile do I need that's got x by x, right? So what tile goes in here, right? So we can see that that's this tile right there, right? That's an x squared tile. Okay? Then what tile goes here? Well, that's an x. Here, that's an x. Down here, that's an x. And here, well, an x is not going to fit, but two of these guys will. Okay? So, you can see that that's x times x is x squared. X times 1 is x. 1 times x, 1 times x, and then 1 times 1, and 1 times 1. So our answer is x squared plus 3x plus 2. Okay? So you can see that if I don't worry about the algebra tiles, right, I could use my expanding idea, and this x squared came from x times x. Then these two x's came from x times 2. Then this 1x came from 1 times x, and these 2 came from 1 times 2. So x squared, collecting like terms, 3x and 2. That's my answer. That was my answer. Okay? So now, when this binomial comes to the party, each binomial part has to say hi to everybody else. Okay? So what that looks like here is a little bit more complicated, right? So the x first goes in and says hi to everybody, right? But then this 2 has to go in and say hi to everybody as well. So that means this 2 comes in and says hi to the x, and it says hi to the 3. Okay? So that means what we end up with is we end up with these two x's interacting. We end up with 3x there. We end up with 2x here, and we end up with 6. Okay? So that means x squared plus 5x plus 6. Okay? So let's just go through one more example. Okay? So first, again, let's go with the algebra tiles. Okay, so the length is 2x minus 3. Okay, and the width is x plus 1. Okay, so this big space here, x by x, is x squared. This is x by x, x squared. Here's 1 by x, so that's an x. 1 by x is an x. Here's negative 1 by x, so that's a negative x. Negative 1 by x again. Negative 1 by x again. And then here is negative 1 times 1. Negative 1 times 1. And negative 1 times 1. Okay? So that gives us 2x squared plus 2x minus 3x and then minus 3. Okay? So let's just go up here for a second and show what's happening here. So 2x times x, 2x squared. 2x times 1 is plus 2x. So there's that part. Then we have negative 3x minus 3. So there's that part. Okay? So you see how it's all really the same? And then we have to collect like terms. So 2x squared plus 2 minus 3 is negative 1x, and then minus 3. So that's the answer.